question I'm going to talk about is question 8, and it's dealing with the tolerance interval, and I'm also going to do question 10 dealing with the tolerance interval as well. So question 8 says the dimensions of this box were measured using a centimetre ruler. What was the tolerance for each measurement? Right, so girls, the tolerance is always going to be plus or minus 0.5 whatever the units are in, and in this case it's in centimetres, so it's 0.5 centimetres plus or minus that. Then it asks me to calculate the difference between the possible maximum and the possible minimum volumes of the box. Give your answer correct to the nearest centimetre cubed. Right, so in this particular box, my length was 12 centimetres, so my maximum length that it could be is 12.5. My width is 7 centimetres, so my maximum width that it could be is 7.5. And my height was 5 centimetres, so my maximum height that it could be is 5.5. So I'm adding plus 0.5 to each of my volumes to get the maximum value that it could be. And when I multiply this out, I get 515.625 centimetres cubed. And then the minimum then, okay, so it's the smallest amount that it could be. So in the diagram, the box, it has 12 centimetres. So the minimum then, I'm taking away this time. Sorry, it's gone a bit. Okay, so I'm taking away. So it's actually going to be 11.5 to get my minimum. Okay, then my weight is 7 centimetres, so I need to take away 0.5, so that'll give me 6.5. And my height is 5 centimetres, I need to take away 0.5, and that will give me 4.5. So my minimum possible volume is 336.375 centimetres to be cubed, and then the difference between them, I got my maximum, take away my minimum, and my maximum then in that case is 179 centimetres cubed. Part 3 of this question asks me, okay, so it says the correct volume, so that's my true volume of the box, is 450 centimetres cubed. Find the percentage error in using the maximum volume of this box. Okay, right, so the maximum volume we got there a few minutes ago was 515.625. So I go 515.625, take away my actual true value that they gave me in the question, which is 450. So I get 65.625. My percentage error is my error over the true value multiplied by 100. So it's my error over my true value, which is 450 by 100, and I get this answer here is 14.6%. Okay, so the next question then I'm going to go through is question 10. So this time it says, using a millimetre scale, Andrew took the height and diameter measurements of a cone as shown. Write down the tolerance interval for each measurement. Right, so we were told that now he's using the millimetre scale, so that means it's plus or minus 0.5 millimetres. Okay, so tolerance is always plus or minus 0.5, whatever the units are in. Okay, and we're using the millimetre scale. Right, but as you can actually see from the diagram, that his diagram is actually in centimetres. So what I did then is I got, okay, so I converted my millimetres to centimetres, so I divide across by 10, and I get 0.05 centimetres, so it's plus or minus 0.05 centimetres. Okay, so then I can say that the tolerance then for each interval of the diameter is 9.8 plus or minus 0.05 centimetres, and the tolerance interval for the height is 8.5 plus or minus 0.05 centimetres. Part 2 of this question asks me to calculate the volume of the cone correct to 2 decimal places. So the volume of the cone, the radius is 9.8 divided by 2, because that was my diameter, and I get 4.9, and the height is 8.5 centimetres. So the volume of the cone is 1 over 3 pi r squared h. So it's 1 over 3, well, pi over 3, r is 4.9 to be squared, and my height is 8.5, and I get that it is 213.72 centimetres squared. Then I'm asked, okay, so it says by calculating the maximum and the minimum possible values of the volume, find the maximum percentage error possible in measuring the volume of the cone. Give your answer correct to 2 decimal places. So the tolerance for the radius is half the tolerance for the diameter, and we worked out that up here, okay, that was 0.05 centimetres. Okay, so the radius then is going to be 4.9 plus or minus, so half of 0.05 is going to give me plus or minus 0.025 centimetres. So then my maximum possible volume is pi over 3 So it's the same formula as up here. 4.925 to be squared, because I'm just after adding on my plus, because for my maximum. So I added on 4.9 plus 0.025, and I get this here to be squared. And my height then, my height was 8.5, and then I need to add on my plus my 0.025 to find my maximum, and I get that the maximum possible value is 217.174 centimeters to be cubed. And then my minimum possible, I'm doing the opposite, so I'm going to be taking away. So my minimum radius is going to be 4.875, and my minimum height is going to be 8.45, and when I work that out I get 210.298 centimeters squared. The maximum error that I could have in this case is 217, what I got from my maximum value, take away my minimum, and I get 3.454 centimeters cubed. Then my percentage error is the error over that true value. Okay, but we were looking for the maximum percentage in this case, so we're going to take my maximum. So it's 217.174 multiplied by 100, and I get 1.57%. That's the percentage error that is occurring in this particular question.